Question number 11. A regular hexagon of a side length 1 is inscribed in a circle. Each minor arc of the circle determined by a side of hexagon is reflected over that side. What is the area of the region bounded by these 6 reflected arcs? Right, we don't have this diagram. Now, the first we need to draw this figure, right? So we have a regular hexagon inscribed in a circle. So now you can see we have this minor arc here. So minor arc here. We have minor arc here. We have 6 minor arcs, right? So this going to be reflect over that side, right? So you have these, we reflect to the other side, right? So I think how to find the area, right? So for a regular hexagon, the normal way we find area just cut into the 6 equilateral triangles. So now you can think about, if I this side, this is the minor arc, right? If I reflect here, that's reflect goes here, right? So you can see that all the other 6 sides showing the same pattern, right? So to find the area required, basically that's going to be this part, right? We have 6 such these. We have 6 such these, right? So then we can just see, to find the area bounded by the 6 reflect arc, so we can just use 6 times each of in this structure, right? And this actually can be treated as 6 this equilateral triangle minus this arc. And what this, right? So this actually is, we're going to focus on this one, right? This is this arc. This arc, we can use this sector. Let me change the color to highlight this. We can use this sector. This sector subtract this equilateral triangle, right? So we can write this actually equal to equilateral triangle minus, so this sector is 1/6 of the circle. So minus this equilateral triangle. Okay, so let's simplify a little bit, right? So this equal to 6 triangle minus distribute, right? Distribute, that's equal to the circle, then plus 6 triangle. So which equal to 12 triangle, equilateral triangle, minus the circle. Right, the circle is easy, right? The circle equal to pi radius 1 times 1 squared, so which is pi. The equilateral triangle, right? We learned this equilateral triangle with side length 1 on 1, right? So the formula going to be square root 3, the side length squared over 4, right? So you can side length is 1, basically that's going to be square root 3 over 4, right? So let's plug in here. That's 12 times square root 3 over 4, so minus pi, which is equal to 3 square root 3 minus pi. So check the answer. B is correct. Question number 12. Which of the following condition is sufficient to guarantee the integers x, y, z certify the equation? X times x minus y plus y times y minus z plus z times z minus x equal to 1. And here you need to pay attention to the words. So integer x, y, z. That's very important, not just real numbers, right? So now we're gonna just do some algebra operation of this expression. We can simplify, we just distribute, we got x squared, then minus xy plus y squared minus yz plus z squared minus zx equal to 1. Right. So now you're gonna see a very interesting algebra manipulation. So that's we're gonna find the perfect square. Right. Before we do that, we multiply the whole expression by 2. Right. So we got 2x squared minus 2xy plus 2y squared minus 2yz plus 2z squared minus 2zx equal to 2. Right. So I'm gonna find the perfect square. So this actually x squared minus 2xy plus y squared. Right. I'm gonna pick one of x squared here, pick one of y squared here. So I'm gonna have one y squared left, right? So minus 2yz. So plus z squared. So I'm gonna get one z squared here. So then we can continue. We have one x squared left, right? We have x squared. We have one z squared left, plus z squared, then minus. So this is 2zx. Sorry, 2zx equal to 2. Right. So now you can see this is perfect square. This is perfect square. This is also perfect square. So then we can find this x minus y squared plus y minus z squared. So plus x minus z squared equal to 2. Right, so this is very important. Right, you can from here, you know, x, y, z are all integers. So then the square of this, the smallest b, you can look at x minus y squared. So x, y are integers. They can be 0 when x equal to y. They can be 1 when they are different by 1. They can be 4 when they differ by 4, etc. Right? But you know, the sum of all these three numbers must equal to 2. What this means? That no one can be, no of these three can be 4, right? So they can only be 0 or 1, right? So one simple example, maybe we let this equal to 1, and this equal to 1, this equal to 0, right? So or we can find a different combination, 2 be 1, the other be 0. But anyway, so we go through this, so we can find D is the correct answer. X equal to Z, and then X and Y differed by 1, right? So you can see, and also X, Y, because X equal to Z, then Y and Z also differed by 1. Right? So D is the correct answer. Question number 13. A square with side length 3 is inscribed in an isosceles triangle with one side of the square along the base of the triangle. A square with side length 2 has 2 vertices on two other square, and the other 2 on the side of the triangle, as shown below. What is the area of the triangle? Okay, so let's mark this one. So we can see here, this has a base is 3. So these bases, this side is 3. So now, I mean, the side of the square has 3. So this square has side is 2. This is 2. Right, and also we know this triangle is a isosceles triangle. Right, isosceles triangle are symmetry left and right. So we can see, if you think about here, we draw here. So we have symmetry here. So you can see this actually is 1.5. So this is 1. So that tells us this actually is 0.5. Right. So you can see here a lot of parallel lines. You can and these tell us similar triangles, right? So if you look at this triangle, that's similar to this triangle, and also similar to this triangle. You can find more similar triangles, right? Let's just use this to find out. So you can see this ratio 2.5. This ratio 2 to 0.5. Right. So these ratio the long leg over the short leg is 2 to 0.5. Right. So the similar if we see these three, if we call this short leg is x, so that's going to be 3 to x. So you can easily find this x equal to, so let's see, this is going to be 4/3. Yeah, right, this is 4/3. All right, actually, this is not, all right, so this actually is 3/4. I make the mistake, 3/4. Right, so if you look at top triangle, so this is cut this by half, this is 1. So then you can find this is y, and also 2 over 0.5 equal to y over 1. Then we find y equal to 4. Right, so then we can find the area of this triangle. Pretty easy, right? So if we want to find the area of triangle, we can find that's going to be half of base times height. So base, you can see this is the 3/4. So this is 3, this is 3/4. So that base half of 3/4 plus 3 plus 3/4. So time height. Height gonna be from here all the way to here. We have 4 here, we have 2 here, we have 3 here. So that's actually is 2 plus 3 plus 4. So which equal to a half. So this is 4. We have 3 plus 12 plus 3. So that's that's equal to 18, right? Right. So time this equal to 9. So we can cancel. This is 9. We got this is 81 over 4. Okay, so we can simplify this, give us 20 and 1/4. Right, this number. So taking all together, the answer is B. Question number 14. Una rolls 6 standard 6-sided dice simultaneously and calculates the product of 6 numbers of 10. Right, you can see the product of 6 numbers of 10. What is the probability that the product is divisible by 4? So this 6-sided dice has a number 1, 2, 3, 4, 5, and 6 on it. It's easy to find out there are total 6 to power 6 different possible ways. Right? Each die has 6 options. 6 die, 6 times 6 times 6 times 6, then 6 to power 6, right? Okay, so we can find the product of all the number of 10. So we find the probability divisible by 4. Some examples like we can have all 4 times 4 times 4 times 4. This definitely divides by 4, right? We don't have to odd be 4. We can have some be 1 or 3 or 5. We can also don't have any 4. We have 2 times 2 times 1 times 3 times 6 times 2, something like that. So from here you can see that's too many. How to count? Right. So you can find this quite hard to count directly. Then we need to think about using complementary. Instead of looking at divisible by 4, the product divided by 4, we are looking for the product is not divisible by 4. So this can be easy because, you know, if we have all of 3 dice shows odd number, they definitely not divisible by 4. So this is one case. And we can have some number be 2, or one number be 2, or one number be 6. One die be 2, or one die be 6. But the rest must be odd. Right? We cannot have 1 more 2 or 6. We cannot have 4, definitely. Right? So basically we just have these two cases, right? Either all odd or 1 is even, 2 or 6 cannot be 4. The rest be the odd. So look for this one, they just see this 6 dice, 1, 2, 3, 4, 5, 6. Each one has 3 options. So this tell us there's going to be 3 to the power 6 different ways. If you look at one die is 2, so the other be odd. So you can see out of these 6 die, 1 be 2. So that's going to be 6 choose 1. Then times, right. So beside this one, except this one, all the rest must be odd. Can be 1, 3, and 5. 3 options for each. Then that's going to be 3 to the power 5. So similarly, if you have one number be 6, let's give you the same number of ways. So now we look at the probability not. So which equal to 3 to the power 6 plus, we have this is a 6 times 3 to the power 5, right? We can write this is 6 times 3 to the power 5, then plus another one, we just multiply by 2 again. So over total possible, that's 6 to the power 6. So we can simplify this. We can factor this 3 to the power 6 out. So then we have this 1, then plus 3 to the power 5. This is actually 3 times 3. Then this gives us 3 to the power 6. We have 2 times 2, which is 4. The bottom one, we have 6 to the power 6. We write 3 to the power 6 times 2 to the power 6. So now you can see this cancel. We find this equal to 5 over 2 to the power 6, which is 64. So then we look at P divisible by 4, which equal to 1 minus 5 over 64, which equal to 59 over 64. So look at the answer, C is correct. Question number 15. In square ABCD, points P and Q lie on AD and AB respectively. Segment BP and CQ intersect at right angle at R. BR equal to 6, PR equal to 7. What is the area of the square? When we just first look at this, we can find a lot of similar triangles, right? Let's see, we have actually right triangles. We have here is right triangle. So this triangle BCR is similar to triangle BQR. So this actually is similar, right? So all we can see these two angles are congruent. These two angles are congruent. And also they are similar to the large triangle AQB. Right? So then how to find? Right. So actually I find a solution that will be good. Basically the first one you're gonna see this one. First step, you're gonna see the triangle ABP actually congruent to triangle BCQ. The reason is, right, these two angles are congruent. We have these right angle are congruent. We also have this leg. So this side length, this is side length, right? So we have this is a angle, side angle, right? So we're gonna see by angle, side angle, we have the angle is we call angle ABP, angle ABP congruent to angle BCQ. Side AB congruent to BC. So we have next angle, angle A congruent angle CBQ, which are right angles. Okay, so with this, we show this. So then we can clearly see QC must congruent to PR, which also tell us this is the QC equal to 6 plus 7 equal to 13. Okay, so we find QC equal to 13. Okay, so this because CPCTC, right? CPCTC. Corresponding parts in congruent triangles are congruent. So now, do you see this picture familiar? We look at the triangle BCQ. This is right triangle. So this is the height. BR is height. We know the hypotenuse 13, right? Yeah, there's many ways to solve this one, but I just think about this geometric mean theorem give us an easy solution. Basically, we can see the geometry mean theorem tells this 6 squared equal to, we call this set to be x, this set to be y. That's equal to x times y. And also we can see x plus y equal to 13. Okay, we just need to solve x and y. Okay, so let me clean the board. We just show the two triangles are congruent, ABP congruent to BCQ by ASA, and find QC equal to 13. So then by geometric mean theorem, we find 6 squared equal to x times y, right? And also we already know x plus y equal to qc equal to 13, right? Then we just need to solve this equation system, right? So various way to do it. One simple way we can see this is the sum. This is product of two numbers. This is a sum, right? A simple way we can just see write a quadratic equation. So t squared minus 13t then plus xy, that's 36, equal to 0. So then we just solve t just xy. Easy to find t equal to 4 and 9. So one is 4, the other is 9, right? So of course we can see this is going to be 9, this is going to be 4. So we find the side length of this triangle just here. So we can see the s squared, the side length squared, which actually is area, equal to 9 squared plus 6 squared. So which equal to 81 plus 36, and the answer is 117. So then we find answer is D.